Special ordered sets, also referred to as SOS, are ordered sets of variables where only one or two contiguous variables in the set can assume non-zero values. There are two types of SOS constraints in Express, Type 1 and Type 2. In Type 1 sets, at most one from a set of variables can take a non-zero value, with all other variables being at zero. They are commonly used in problems with binary variables, where at most one can have the value 1, such when deciding for the location for a new facility amongst a set of possible locations in facility location problems. SOS Type 2 constraints apply to a set of non-negative variables, where at most two can be non-zero and must be consecutive in their ordering. This type of constraint is commonly used to approximate nonlinear functions. SOS constraints can be added to an Express problem via the problem.add_SOS method. The method receives as arguments the list of variables composing the SOS constraint, weights that define the ordering for the constraints to enforce, the SOS type, and, optionally, a name. The example shows an SOS Type 1 constraint being added for two selected variables x with fixed weights, and an SOS Type 2 constraint for the whole set x, where the weights increase proportionally to the index position of the variable. The Jupyter Notebook example SOS.IPYNB shows how to define special ordered sets and how to retrieve data related to this special type of constraint. In this example, variables of various types are created first, and then a constraint containing all variables is added to the problem. Variables v1 and v2 are then turned into a special ordered set of type 1 by using the add_SOS method, meaning that at most one of these two variables can be non-zero, with v2 coming first in the ordering defined by the weight coefficients. A name is given to the SOS constraint via the name argument, which accessed via the name property of the object S, as shown in the output cell. After defining an objective and optimizing the problem is written to an external file with LP format, which includes the SOS constraint. In the output cell, we can confirm that only v2 has a non-zero value in the optimal solution due to the SOS constraint we have defined. In the last code cell, the SOS constraint is removed before exporting another version of the LP file, but without the SOS constraint.